Welcome to the 42nd video in our series about Unix tools. In this video, I will show you more tools used to work with object files and executable files. We already know about the file command, but it only tells us what kind of data is in a file. If we want details, we know about cat for text files, like the .c or .h source code. For binary data, the only tool we know is hexdump, and usually with the -vc options. And while that does show us the value of every byte in a file, it does not tell us anything about the structure or meaning of those bytes. I have repeatedly claimed Unix is loved by many developers because it has many helpful tools. Well, it's time to introduce some more of them to you now. If I get the focus on the correct window. There we go. So last time, you can see we were in C land, and we had these files. And we had just run hello and verified that it worked. And I said, how do we know what's in here? If we try to nano that, it looks like gibberish. I mean, we can see a few things, but not much. We see that ELF, and if you remember from the file command, I said ELF lets you know it's some kind of executable or object file. But that's all we've got here. That's not very useful. And if we try cat, you'll actually probably hang your terminal. We could use hexdump. And you see it's quite long. So let's use our magic. And you can see, all right, there's a few things I can see in there. Hello.c. Main was one of the functions, greet was one of the functions, but really, I can't understand much of this. So we need a better tool. And there are two tools that I'm going to talk about now. First is nm. And if you try to do a help on nm, like everything else, it has so many options, they scroll off the screen. But this says, list symbols in a file. And then there are lots of options that we can use. So let's take a look at this. And you can see, wow, undefined, define, weak, all this stuff. But this looks pretty good. Index for symbols from archive members. I kind of like that. That index usually shows you a lot. And then you look at this and you say, use debugging information. Well, we didn't compile with debugging, so we don't have that. And we look some more and we say, ignored. I don't think we need that one. And format. Format can be BSD, System 5, POSIX, or just symbols. And the default is BSD. So, wow, overwhelming. Let's just try nm on hello.o. And we can see, greet and main. And those are the two functions mentioned. Main is actually in there, and greet is not in there. And you might ask yourself, what is this U? What is this T? The U says that it's not defined, it's undefined in this file, and T says it's defined in this file. And this tells you where. So fine, let's look at the other file. And we say, okay, nm helpers.o. Now work with me. What should be in there? We need something like t-greet. Oh, look. T-greet is in there because it's defined. What about the put-s? And you say, I didn't use put-s. I never used put-s. In fact, I used printf. Well, you asked for printf and you got put-s. This is part of optimization that you didn't control with the compiler. So the compiler said put-s will be faster because you don't have any placeholders in here. It's just a literal value. And put-s is faster than printf if you just need to print a literal string. Okay. At least we can see the names of functions and we can learn that I called it, but it's not in here, or it's in here. That's helpful. At least you can figure out which .o has what. But let's say you want more. You know, people are greedy. Everybody is sometimes. And you want more. And you say, helpers.o should have more information than that. Is there a better tool? NM showed me the symbols. Well, there's an object dump tool that goes into more detail and display information from object files. And then, wow, it's got a million options. And it would take us a month to learn all of them. But let's assume you have a helper like me, and he says, try that, XSD. We'll run that on hello. Oop, if I spell it correctly. And look at that. Look at that. I got disassembly of main. And here is the assembly language sequence of instructions, and on the left are the actual hex bytes for those. And you'll see some places where 0000 and they tell you the linker is going to have to fill that in. Okay, and it says PLT32, something about that. And 32 divided by 8 is 4, and you see 1, 2, 3, 4. Those things are going to be filled in by the linker later. That's the linker's job. This is where we tried to call something. And it says, okay. I'm pretty happy with that. Let's try it on the helpers.o and see what we get with that. And helpers.o has got some more stuff. And it says, this is the code for the greet function, and it shows you actual assembly language instructions. But because we didn't compile with full debugging, it's a little difficult to figure this out. Okay, and you'd see call, and you think you're going to call greet, and greet is the function I'm in. Is this a recursive call? And remember, no, this is greet plus some value. And again, you see all those zeros. They need to be filled in by the linker because we've got another relocation. But here's a hint. It says I'm calling put-s. So we've got a lot more information, even though we didn't specially compile. And if we scroll backwards, you can see there's even more. They put the assembly language dump at the end because that's what most people want to see. But it tells us more. Here are the segments inside the code. It dumps the symbol table and it tells you what's defined in here. Greet, and it's in this file, and puts is undefined, which tells the linker you're going to have to go look for it. and it turns out that's going to be in the libc, C standard library. Read-only data. Yeah, there's our string, hello BUU. And you say, what's this dot? What's this dot? I don't understand this dot. HELLO space BUU, and you see it's a null. You have to mark the end of string. Okay, we've learned a lot more. In fact, more than most people want to know. We've used nm if we just want the symbols. We use objdump with XSD if we want to get actual assembly and a list of the segments and the symbol table and the full details. And we've run out of time in this video again, so I want to thank you for sticking with me so far. Please come back for the next video when I show you how to automate the compile and link process, because nobody wants to type those long GCC command lines every time. But for now, thank you for listening.